Hi everyone, today in this video let us try to understand the concept called operators in Python. In the previous videos we have covered all the concepts regarding the input, output and several basic concepts in the Python, and now let us try to understand the operators in Python. If you haven't seen the previous videos, please do watch the Python basics playlist in our channel. Okay, now let us discuss the concept called operators in Python. There is nothing in theory that we need to discuss regarding the operators in Python. So let us try to see various examples and different types of operators that are available, and let us try to understand the concept behind them. So now let us try to understand the basic arithmetic operators and their way of operation. Here you can see that we have initialized a variable a with the value 15 and variable b with the value 7. So now let us try to see each operator in the below examples. When you try to print a plus b, we can see that the output is 22, because here internally what is happening is that the value a plus b is just generally added and the output is 22 is printed here. And when you are trying to print a minus b, we know the subtraction operation, right? In the same way, the value 7 is now subtracted from the value 15 and the output is 8. In the same way, we also know multiplication operator. The star is called multiplication operator, which is used to multiply two values, and we are getting the output 15 7s are 105. And then the backward slash here indicates the division, the normal division in our daily life. The backward slash indicates the division operator. So 15 by 7, when you divide 15 by 7, we'll get the value 2.14 something, because this is not a proper division, right? 15 divided by 7 is not a proper division, so that's the reason we are getting some 2 point around some value. And when this modulo or this percentile symbol indicates the modulo division. And what we do in the modulo division is that when you try to divide 7 by 15, you will get 2 and then 14, and then what is the remainder here? When you try to see, the remainder value is 1. So the modulo symbol is used to give the remainder when you try to divide a by b. So that's the reason we are getting 1 here. So the modulo operator is used to get the remainder when you try to divide a by b. And then when you try to observe these two backward slashes, this indicates that when you try to divide 15 by 7, it will try to take the integer quotient part only. It won't take the fraction part, it won't take the exact division part, it only takes the integer part. Here the integer part, once we perform this division, is 2. So that's the reason we are getting the output as 2, because these two backward slashes are called as integer division operators. So what will happen is that, as I said previously, the integer part of the quotient is now considered as the output. It is also called as floor division. Why it is called floor division? This is called floor division because when you try to observe, the actual coefficient would be 1.42 and so on. So this is the actual quotient value when you try to divide 15 by 7. But what we are trying to do, if you assume that the next value that is coming after 2 is 3 and the below value after 2.14 is 2, if you assume like that, this is called seal, because we are going to seal. I mean, in the sense, in the house, when you try to take a house, the top part is called seal of the house and the bottom part is called floor of the house. In the same way, when you try to observe these three values as a box, this 3 part is called seal, which is the upcoming part, and then this 2 part is called floor, because this is the bottom part. So what we are trying to consider as output here, we are trying to consider 2 as output, which is a bottom part, and this is called floor. So that's the reason we are calling this division as floor division. Now let us try to see what is this a star star operator. B means power. This a star star operator indicates power, which means that is a power b. When you try to see 15 power 7, you will get some large value like this. So these are basic arithmetic operators that are present in the Python. Now let us try to see second kind of operators that are present in the Python, that is comparison operators. Here we are initializing a variable x with the value 10, y with variable y with the value 20. So what we are trying to do here in this first line, we are trying to compare x double equal to y. This indicates that we are trying to compare the value in the variable x with the value in the variable y. When you try to compare these two values, what we are trying to do, we are trying to check whether these two values are equal or not. When you try to see, these two values are not equal, because x contains 10, y contains 20. These two values are not equal. So that's the reason we are printing the output as false. So the comparison operators gives the output either as false or true based on the given comparison, because here we are comparing whether they are equal or not. So that's the reason we are getting the output as false. And then when you try to observe this symbol indicates not and this symbol indicates equal to, and that combinedly they are totally indicates that not equal, which means you are saying that x is not equal to y. The x contains the value 10 and y contains the value 20. So 10 not equal to 20. So this is true, right? So that's the reason we are getting the output as true. And now we all know this operator, right? That is greater than, which is used to say that the left side value is greater than the right side value. When you try to see the left side value, that is 10 greater than y, that is 20, which is a false statement, right? Because 10 is less than 20. So that's the reason we are getting the false. Whereas we can see that less than operator. When you say that x less than y, that is 10 less than 20, we can say that this is true because 10 value is less than 20. So that's the reason we are getting true here. In the same way, we can see that the greater than or equal to, that is, which indicates that the value x may be greater than or may be equal to the value y. But when you try to see, the value of x is not greater than y because the value of y is 20, and it is not equal to y because the value of y is 20 and value of x is 10. So that's the reason the statement is false. So that's the reason we are getting the output as false. In the same way, less than or equal to, here when you try to observe x less than or equal to y, here the value of the x is 10 and the value of the y is 20. So the value of the x is less than the value of the y, and it is not equal to, but we are saying that less than or equal to. Either if anything is right, we will say this as true. So that's the reason it is less than. The one thing is right? So that's the reason we are saying it as true. So the output is true. Now let us try to understand the concept called logical operators. We can see that there are 3 logical operators that are present here. Let us try to understand each logical operator in detail. So when here what we are trying to do here in this line, we are trying to initialize the value of x to 2 and value of y to 11. So the value of the x equal to 2 and the value of the y is equal to 11. What we are trying to do in the first statement? In the first statement, we are saying that x value is less than 5. So when you try to see that is 2 less than 5, we are using the operator called AND. Let us try to understand the use of AND. Okay, let me write the content first. And then y greater than 10, the y value is 11 and the 11 is, okay, y greater than 10, that is y value is 11 greater than 10. So when you try to see, this is what we have, right? So this is the final thing that we are having in that print statement. So when you try to observe here 2 less than 5, which is a true, the first part is true. When you try to observe the second part, 11 greater than 10, this is also true. So that's the true and true. So that's the reason we are getting the output as true. The AND operator works like this. And if the first part is true and the second part is false, the output is false. If the first part is true, the second part is true, then the output is true. If the first part is false and the second part is false, the output is false. If the first part is false and the second part is true, even though the output is false. So this is how the AND operator works. Here there is one point that you need to keep in the mind. So what I am trying to explain here is that, so when you try to see, if the first part is true, then only the second part will be checked by the Python virtual machine. Keep that in mind. Only if the first statement part is true. So only in these 2 cases, we will check the second part, whether the second part is correct or not. In these 2 cases, if the first case is false, we would never check the second cases. Please keep that in mind. Why we don't check the second cases? For the uncondition, that to be true, the both cases should be true. When you are failing in the first case, then there is no need for us to check in the second case when we try to understand about the AND operator. So keep that in mind that only if the first case is true, then only we will check the second case in the AND operator. Okay, here when you try to see, this both cases are true. So that's the reason we are getting output as true. Now let us try to see OR operator. Here what we are trying to do here, what first comparison says that x less than 5, that is 2 less than 5, and the second comparison says that y less than 4, that is 11 less than 4, and the first part says that 2 less than 5. So and the middle we have OR operator. So this is the final statement that we are having there. What does this happen? When you try to see the first part is true because 2 less than 5. The second part is false, but the output of this, we can see that here that the output of this is true. Why? Because operator table of OR is different from the AND. So for OR to be true, there are some conditions, right? If the first part is false and the second part is true, then the output is true. If the first part is false and the second part is false, the output is false. If the first part is true and the second part is true, the output is true. If the first part is true and the second part is false, even though the output is going to be true. So this is the table for the OR. So to understand OR in detail, there is one point that we need to discuss regarding the OR. Only if the first case is false, then only we will go and check the second case in the OR operator. The Python virtual machine only check the second case. If this is the second case and this is the first case, the Python virtual machine only checks the second case if the first case is false. In these 2 cases only, the Python virtual machine is going to check the second cases. If the first case itself is true, there is no need for the OR operator or the Python virtual machine to check the second case, because for OR operator to give the output as true, only one value need to be true. So when you try to see that the first value is by default true, then there is no need to check the second value, because for OR operator, there is no need to check for the second value. So this is how the OR operator works. Now let us try to see the third operator, that is NOT. We have seen the AND, right? Let us try to understand what does NOT operator do. Here what we are trying to do, we are saying that x is less than 5 and y is greater than 10. Let us check. The value of the x is 2 and which is less than 5. That is true. And the value of the y is greater than 10. That is 11 greater than 10. Because it is an AND operator, even the first case is true, we need to go and check the second case. That is 11 greater than 10. That is true. So the both cases are true. So that's the reason the output should be true. But here we can see that the output is false. Why? Because the NOT operator, we are applying NOT operator to this statement. That is, the output of this value is going to be true, right? So NOT of true will result in false. What if you have greater than here instead of less than? What if you have greater than? Then the condition here would go false, right? The condition is now becoming false. Whenever this is false, the AND operator will not check for the second case, because the AND operator, if one thing is false, definitely the AND output should be false. So because of this false condition, the output here will turn to false. And when you are applying NOT on false, you will get the value true. Let me show you this example here. Instead of this writing example, I will show you this example in the code part. So here we can see that I just have swapped the less than value with the greater than value. So that's the reason this part is becoming false. And even though this part is true, we don't check this part because of the AND operator. And finally, when you try to apply false on the NOT, the output would be true. So this is how the NOT operator works. So there is one more thing that we need to say about the NOT operator. Keep that in mind. This might help you in some other cases. NOT of any number is false, because by default in the Python virtual machine, considers a number as a true value. What I am trying to say is, if you apply NOT of 5, by default the 5 is considered as a true value. When you are trying to apply NOT on 5, you will get the output as false. The only number that is not considered as true is 0. The 0 is not considered as true. So when you try to apply NOT on 0, number 0, you will get the output as true, because the 0 by default is considered as false by Python virtual machine. So that's the reason when you try to apply NOT on false, the output would be true.